Hey guys, so we're going to look at 4.3 right triangle trigonometry. So here are the 6 trig functions that we looked at last time, and it's all in reference to this right triangle. It has to be a right triangle. And then you've got this angle theta, which is not the right angle. It's one of the other two. Theta could be on the other angle as well, but it's one of these acute angles. And then based off where theta is, you have the side opposite of theta and the side adjacent or next to theta. Beware, the hypotenuse here is always across from the 90-degree angle. So the hypotenuse, sometimes people think that's the adjacent side because it is next to theta, but your adjacent side is the adjacent but not the hypotenuse. It's got to be this other remaining leg of the right triangle. So we are going to use these 6 trig functions on the triangle below. First things first, we're going to find the hypotenuse. So I will use Pythagorean theorem. I'm going to do my a squared plus b squared equals c squared. All right, the a and b you could have labeled them, 4 is the a and the 3 is the b, that's fine, but the c has to be the hypotenuse. All right, so I'm gonna get a 9 plus 16 equals c squared. And if 25 is c squared, I will take the square root of both sides, and a 5 is the hypotenuse c. Okay, and then we're gonna use that for the other trig functions here. Sine is the opposite over hypotenuse. So the opposite side from theta is the 4, and then my adjacent side next to theta is the 3. So I will do my sine, I'll do my opposite over hypotenuse, so in our case a 4 over 5. My cosine. Cosine is the adjacent over hypotenuse, and we already labeled adjacent is the 3 over the hypotenuse 5, so 3/5. And then my tangent is opposite over adjacent. So opposite is a 4 over adjacent 3, so 4/3. All right, so then we are going to do the next 3 trig functions. My cosecant, zoom out there a bit, okay. So the cosecant, I did that in purple as well because instead of opposite over hypotenuse like sine, it's hypotenuse over opposite. It is the reciprocal of sine. So instead of 4/5, it is 5/4. Again, hypotenuse over opposite. And then my reciprocal of cosine is secant. Instead of adjacent over hypotenuse, it's hypotenuse over adjacent, which in this case would be hypotenuse of 5 over adjacent 3. It's 5/3. And then my cotangent is the reciprocal of tangent. So instead of opposite over adjacent, it's adjacent over opposite. Also in terms of the 4/3, the reciprocal would be 3/4. Okay, so let's look at these special right triangles. So it's a 45, 45, 90 triangle and a 30, 60, 90. Those are talking about the angles here, 45 degrees, and then there's a 90-degree angle. So that's why it's called a 45, 45, 90 triangle. And the other one is a 30, 60, 90. Okay, so on your 45, 45, 90, the 2 legs, those are both the same length. They're both x. And the hypotenuse here across from 90, that is whatever the legs were times root 2. It's your x root 2. So I'm going to apply that to number 2 here. Because I see a single 45 degree and then I've got a 90-degree angle, I do know that all triangles, their angles add up to 180. So if I subtract off the 90-degree angle and the 45-degree angle that we already have, looks like all we have left is 45 degrees for this last angle. So this is a 45, 45, 90 triangle. And it looks like the hypotenuse here which is across from my 90 degrees. The hypotenuse should be like my x root 2. And the hypotenuse across from my 90 degrees in this case is a 1. So I will put that equal to my x root 2. All right, and I'm going to solve for x. Maybe I'll put this over to the side here. I'm going to divide by root 2 on both sides. And I need to rationalize the denominator. I'm going to multiply by root 2 over root 2 to get root 2 over 2 as my x. All right, and then the x is both legs. They're both the same distance. So I've got a root 2 over 2 and another root 2 over 2. Okay, so in order to solve the triangle, that means you should have all 3 angles and all 3 sides, which now we do. So we have solved the triangle, and then part B, find all 6 trig functions of 45 degrees. So if I'm treating this 45-degree angle, honestly, I could do it the bottom right one or this top one, either way. Either of the 45-degree angles will have the same 6 trig functions. So sine of 45 degrees is opposites. Okay, let's label which one's opposite of 45. My opposite side is the root 2 over 2. The adjacent side is another root 2 over 2. And the hypotenuse was the 1. Let me get rid of that. Hypotenuse was a 1. Okay, so sine is opposite over hypotenuse. So it's basically a root 2 over 2. My cosine of 45 degrees. Cosine is adjacent over hypotenuse, so it's another root 2 over 2 for the adjacent over the hypotenuse of 1, so ends up as root 2 over 2. My tangent, tangent of 45 degrees is my opposite over adjacent. So it's a root 2 over 2 divided by another root 2 over 2. As messy as those are, it's the same thing divided by itself. So it ends up as a 1. Okay, so here are my 3 main trig functions, and then I can do my cosecant of 45 degrees. I can do that as the reciprocal of sine. So instead of root 2 over 2, I could do 2 over root 2. Again, I need to rationalize the denominator. So this turns into a 2 root 2 over 2. The plain 2's there, those divide out, and I'm left with a root 2. The reciprocal of cosine is secant. So my secant of 45 degrees is also the reciprocal of this. So instead of root 2 over 2, it is 2 over root 2. And I would do all the same simplifying that I did here. It ends up as a plain root 2. And my cotangent of 45 degrees is the reciprocal of tangent 45 degrees. So I end up with this same fraction that simplifies to a 1. All right, so there are all 6 trig functions off of 45 degrees. Let's look at the other special triangle. This was a 30, 60, 90 triangle. The x is not on both of the legs. The x is across from the 30 degrees, and then you have to use that x to find both of the other sides. Okay, so on number 2 here, I can see that I have a 60-degree angle, and then I have this box of a 90-degree angle. Oops. All triangles add up to 180 degrees. So if I take off the 90 and the 60, I have 30 degrees left in this last angle. Okay, and then they gave us the hypotenuse across from the 90. So that's going to be equal to, off of my 30, 60, 90, it's equal to the 2x for my hypotenuse. So I'm going to set this 1 equal to 2x. So divided by 2 on both sides, 1/2 is my x. Now the x goes across from the 30. So across from my 30 is, in our case, a 1/2. That's what our x is, a half. And then the only side I'm missing now is right here. It's across from the 60. And across from 60 is our x times root 3. So this is going to be a 1/2 times root 3, which really I can just say root 3 over 2. It's the same thing. So I'm going to put root 3 over 2. Okay, so as far as solving the triangle, we now have all 3 angles and all 3 sides. We have solved the triangle. And we are going to find all 6 trig functions of 30 degrees. So in this case, if the 30 degrees is the angle we're going for, opposite of the 30 degrees is the 1/2. The hypotenuse is a 1. And adjacent to the 30 degrees is root 3 over 2. So I'll start this over here. My sine of 30 degrees is opposite over hypotenuse. So it'll be a 1/2 divided by 1. Do I really need to divide by 1? No, I'll just leave it as 1/2. All right, my cosine of 30 degrees. My cosine is adjacent over hypotenuse. So this is going to be a root 3 over 2 divided by 1. And again, I don't really need to put divided by 1. I'll just leave it as root 3 over 2. And then tangent of 30 degrees is the opposite over adjacent. So these are fractions we have to divide, the 1/2 over the root 3 over 2. So to simplify this, I will multiply by the reciprocal. The 2's divide out, great, I got down to a 1 over root 3. I still have to rationalize the denominator though. So I will end up with a root 3 over 3, dividing by a whole number. Okay, so those are our main 3 trig functions. Let's then find the other 3. We're going to do the reciprocals. The cosecant of 30 degrees, instead of 1/2, I'm going to get 2 over 1, or just 2. Secant is the reciprocal, I'm doing secant of 30 degrees, reciprocal of cosine 30 degrees. So instead of root 3 over 2, I will get 2 over root 3, which I do have to simplify, multiply by root 3 over root 3, so I get 2 root 3 over 3. There's my secant, and I'm squeezing here my cotangent of 30 degrees, which is the reciprocal of my tangent 30 degrees. I think because this stuff is all equal to each other, it's just getting simplified, simplified, simplified. I think I'm going to take this one, 1 over root 3. It's equal to what I ended up with. I just think the reciprocal of this guy is going to look a lot better. So if I do the reciprocal of 1 over root 3, I get root 3 over 1, which is just a root 3. If I did the reciprocal of this other one, I would have to simplify, and it would simplify down to the same thing. I just thought it would be easier to do the reciprocal of 1 over root 3. Okay, they also want us to find all 6 trig functions of pi thirds. Now, I always have like some angle, but they give me angles in degrees so far. This angle is in radians. So let's see what part of the triangle it's talking about. Pi thirds multiplied by 180 over pi. I'm turning it into degrees. Okay, this ends up as 60 degrees, which means I'm going to change what I had in green on the 30, 60, 90. Okay, I'm going to go off of this 60 degree angle now, which means that the opposite side is now the root 3 over 2. The adjacent side is the 1/2. The hypotenuse is still the 1. Okay, so let's find all 6 trig functions of 60 degrees, or pi thirds. So I will do sine of, let's do sine of pi thirds. It's the same thing as sine of 60 degrees. Sine is the opposite over hypotenuse, which my opposite was root 3 over 2, divided by 1. I don't really need to divide by 1, so I will leave it as root 3 over 2. And then my cosine of pi thirds, or in other words, cosine of 60 degrees. Cosine is adjacent over hypotenuse, so it's like a 1/2 divided by 1, which I will leave it as a 1/2. And then my tangent of pi thirds, or tangent of 60 degrees, same thing, is opposite over adjacent. So root 3 over 2 divided by 1/2, which if I simplify this, I'll multiply by the reciprocal of 1/2, so I multiply by 2 over 1, and this ends up as a root 3. All right, so I found my 3 main trig functions. I can then do the reciprocals to get the cosecant of pi thirds, I'll just start with that. Okay, so if I do the reciprocal, I get 2 over root 3, which I do have to simplify. So I multiply by root 3 over root 3, I get a 2 root 3 over 3. It's considered simplified when I do not have a radical in the denominator. Here I'm going to do the secant of pi thirds, which is the reciprocal of cosine. So instead of 1/2, I get 2 over 1, or just plain 2. And then my cotangent of pi thirds is the reciprocal of tangent. So instead of, this is like a root 3 over 1, I get like 1 over root 3, which if I rationalize the denominator, I end up with root 3 over 3. Okay, all 6 trig functions. All right, now let's talk about complementary angles. Complementary angles have to add up to 90 degrees, or if we're talking radians, we're talking pi halves radians. All right, so here are some trig identities. These are things that are true every time. And we're gonna have to memorize these identities. So I don't know if you wanna make yourself flashcards or whatever it is you gotta do. We do need to memorize these identities. And I did wanna clarify this right here. This at the bottom says that sine squared of theta, that's the same thing as sine of theta all squared, but it is not the same thing as sine of theta squared. This one is just squaring your angle as opposed to squaring the entire sine of theta. So beware, I see a lot of people try to interchange these equally, but this guy is not equal to the other two. All right, so before I see you guys next time, maybe look at these identities, start memorizing, and I will see you on Monday.